Hello, Algebra 2. I hope you guys are having a fantastic day. So I just have to warn you ahead of time. This is my first time with a new program making this video, so I apologize if it's not the best quality. We're going to work on it. We'll see how this works out. So the lesson today is 2.5, which is about complex numbers and roots. So I've been telling you guys about, taking square roots of negative numbers and things, and so that's what today is going to be about. So we're going to be able to, by the end of today, define and use imaginary and complex numbers and solve quadratic equations that have complex roots or complex solutions. Okay, so first we're going to take a look at the graph of x squared plus 4. Okay, that is your regular y equals x squared graph, but just shifted up 4. Alright, so here's your y equals x squared graph. And then we are going to shift it up 4. So let's do that in blue, because I love blue. This is my favorite color, by the way, if you didn't know that. Okay, so we shift everything up 4. So then that point, that point, that point. Okay, and then we just kind of create our graph like this. And then that is y equals x squared plus 4. Okay? So what do you notice about the intercepts? Okay, well, clearly on the y equals x squared plus 4, there is no x-intercept. There's a y-intercept at 4, but there are no x-intercepts. Does that mean that there are no zeros? Well, we kind of talked about how that's not the case. Okay, so you can still actually solve for zeros, they're just not going to be real. Okay, so you have no real zeros or x-intercepts. But as you're going to see very shortly, that we do actually have imaginary intercept, or, okay, that's a bad word, imaginary zeros. So for this unit, we're going to need the imaginary unit, okay, and that is the basic, where all of the imaginary numbers come from. So we call that I, and I is equal to the square root of negative 1. So anytime you see the square root of negative 1, simplified, you make it equal to I. Super easy. Alright, we're also going to need to know the difference between like a real number, an imaginary number, and a complex number. So complex numbers are in the number system that we will use pretty much the rest of our lives, no matter what you do in your life, okay? There's only going to be complex numbers as far as we're concerned. Complex numbers include both real and imaginary numbers, and then numbers that are mixed between real and imaginary numbers. Okay, so your real numbers are any numbers without an I included. Okay, so 2, square root of 2, pi, negative 1. Okay, all of those are real numbers. Imaginary numbers are any numbers that have I in it. So 2i, or I times the square root of 3. Okay, those are all going to be imaginary numbers. And then complex numbers include both of those, but then also include numbers that are mixed between real and imaginary. So, for example, a number of this form, right, a plus bi, is a complex number, okay? And so, for example, you might have something like 2 plus 3i. And if you look, you have a real part, and you have an imaginary part. And the whole thing together, real plus imaginary, equals a complex number. Now, sometimes numbers can be deceiving. So like if I have the number 2, that's still a complex number because I can write it as 2 plus 0i. So it's still a complex number. Same thing with imaginary numbers. If you have 3i, this is an imaginary number, but it's also a complex number because I could write it as 0 plus 3i. So officially, this a part here is the real part. And the plus bi could be also a negative b, right? So it could be a minus 2i or something like that, is called the imaginary part. Okay, and you can only combine like terms. So you can't combine a real part and an imaginary part. So that helps when we're solving equations, which you'll see, complex equations, which you'll see in a couple of minutes here. So the next thing we're going to need is the complex conjugates, and these are all the definitions that we'll need for the rest of the examples. Complex conjugates are numbers that are really important, but if a plus bi is a complex number, then its complex conjugate is a minus bi. Notice that the real part stayed the same, positive or negative, right? That didn't change, but what did change is the imaginary part. And a lot of times people get confused because maybe I'll give you a tricky problem and I'll say, oh, what's the complex conjugate of 2i minus 3? And you'll say, oh, it's 2i plus 3. But no, don't do that, because you're not changing the sign of the real part, you're changing the sign of the imaginary part. So the complex conjugate of 2i minus 3 is negative 2i minus 3. It's always the imaginary part that changes. Now we're just going to try a couple examples, okay? So simplify the following. We've got the square root of negative 16. So I can break this up, which is the awesome thing about square roots, as the square root of negative 1 times 16, right? That's all under the square root. And because those are both multiplied together and under the square root, I can take it as the square root of negative 1 times the square root of 16. Square root of negative 1 is I, and square root of 16 is 4. We usually write the number first, just like as if we were using it as a variable. Okay, so 4i. What about the square root of negative 50? Same thing. That square root of negative 1, that turns into square root of negative 1 times the square root of 50, or times 50. So that becomes I times the square root of 50. And then we can simplify the square root of 50 a little bit and make it I times the square root of 25 times 2. Square root of 25 is just 5. So we're going to pull that out front. I times 5 times the square root of 2. And just for notation's sake, that's usually 5i root 2. But, you know, that's just notation because math people are OCD. Okay, so here's something really interesting. If you simplify the powers of I, you've got I to the first, I squared, I to the third, I to the fourth, I to the fifth. If you simplify those, you'll notice something interesting. I'm going to show you the first couple. So I to the first is just I, right? Anything to the first power is just itself. Now I squared is I times I, right? And remember that I is the square root of negative 1. Or, even better, let's leave it as I squared. Square root of negative 1 squared. Remember, square roots and squares cancel each other out. So I'm just left with negative 1. So I squared equals negative 1. Let's look at I cubed. Okay, that is I squared times I. Remember that I squared from earlier is equal to negative 1. So I'm going to replace that with a negative 1 times I, and I get negative I. Okay. And I'm actually going to let you figure out the rest of them on your own. And then we'll talk about them in class. Alright, let's try the next couple examples. So the next ones are a couple equations, okay, and it says find the values of x and y that make the equations true. And you've got 2x plus 8i equals negative 10 plus 4i. So this may seem really complicated because you've got an x. Oh, there's no y in this case, but that's alright. I think it's, yes. Yeah, we'll just go with that. So the thing that's true about these equations is that you cannot combine imaginary parts and real parts. So if you know something's real, Oh yeah, this isn't going to work. Oh, hold on. We need to change this problem. Okay, this is a better problem. 2x plus 8i equals negative 10 plus 4yi. So the nice thing is, in the problems, it will assume, you're going to be assuming that x and y are real numbers. I didn't actually state that in this problem, but you want to make that assumption here. So what's nice is that you know that the 2x and the negative 10 are both real. And you know the 8i and the 4yi are both imaginary. So you can take them and separate them into two separate equations. So you've got 2x equals negative 10. Okay, so that's the whole real side of it. And then you also know that 8 has to equal 4y, because that the imaginary parts have to be equal to each other. So then you just solve those. So you get x equals negative 5 and y equals 2. Okay, and then that solves the equation. And we can do the same thing for the second problem. You've got negative 6 and 3x, that's your real part. So you've got negative 6 equals 3x. And then for your imaginary part, you've got negative 6y equals 12. And then you can solve each of those individually. Okay, so x equals negative 2, and y also equals negative 2. Okay, not too bad. Alright, next type of example might involve solving equations, like quadratics. Okay, so you've got x squared plus 32 equals 0. Now in this case, you can just subtract 32 to the other side, and you get x squared equals negative 32. Take the square root of both sides, and what happens when you take the square root? Yes, you get a plus or minus, and so you get x equals plus or minus the square root of negative 32. Then we just simplify that to be plus or minus I, because that square root of negative 1 pulls out, times the square root of 32. And then you can simplify that a little bit more, because 32 is 4 times 8. And actually, let's go with 16. I think that'd be even better and simplify even more. So 16 times 2. So then I can pull out the square root of 16. We've got plus or minus I times the square root of 16 times 2. And the square root of 16 is 4. So I have plus or minus 4 times I times the square root of 2. And then those are my two solutions for my equation x squared plus 32 equals 0. Alright, for the next example, I've got negative 5 equals x squared plus 2x. Now, this looks more like a quadratic I'm going to have to do completing the square on. So I want to make sure I get everything on one side and have a 0 on the other, because it doesn't really work out if you don't. Okay, so we got x squared plus 2x plus 5. And then I want to complete the square. So I take the 2, divide by 2, I get 1, square it, I get 1. 1 squared is 1. Add it in, subtract it out, and I get 0 equals x squared plus 2x plus 1 plus 5 minus 1, so plus 4. This whole thing simplifies to x plus 1 times x plus 1, or x plus 1 squared plus 4 equals 0. Okay, and then you would take that equation and solve it. I'm going to actually erase a little bit so that you can see better. Alright, so subtract 4 to the other side, minus 4. So I get negative 4 equals x plus 1 squared. And now I can take the square root of both sides. And the square root and the square cancel. And now the square root of negative 4 is just 2i. And that equals x plus 1. Don't forget your plus or minus when you take the square root of both sides. I almost did. And then you subtract 1 from both sides. Now remember, this is real. This is imaginary. Can't combine them. So I have negative 1 plus or minus 2i equals x. And then those are my two solutions. Now take a minute and look at the answers for this quadratic. I have negative 1 plus 2i and negative 1 minus 2i. what's true about these two numbers? Well, if you go back to the first page and remember the complex conjugates, right? A plus bi and a minus bi are complex conjugates. That is not a coincidence. Okay? Anytime you solve an equation and you have one complex number, you will always get the conjugate of it as well. It's always going to be the second answer, which is kind of a cool little thing. And the last couple examples, it says find each complex conjugate. 5 plus 4i, the complex conjugate changes the imaginary part, 5 minus 4i. 3 minus I changes the imaginary part, 3 plus I. And then here's one that's tricky because it's out of order. I plus the square root of 5. The complex conjugate is negative I plus root 5. Okay? And so I have this last statement here. If one complex number is a solution to a quadratic equation, then what do you know? Well, just like you saw in the example up here, okay, if you get one complex number, then you also have the complex conjugate is also a solution. Woohoo! And I think that's pretty much it for the lesson today. Oh, I forgot to do number 4. Sorry, my bad. Okay, so this is a complex number, and it's also an imaginary number, right? You could write it as 0 minus 4i. So its complex conjugate is 0 plus 4i, or just 4i. Okay, there you go. Have a good day. Bye-bye.